Welcome to week 4. We've been talking about algorithms. Talked about a couple of kinds of algorithms, and this tutorial is about the linear search algorithm, and we're just going to go through an explicit example. It just reiterates what we talked about in the lecture and in the notes. If you want to follow along, you can look on the homepage and tutorials for week 4, and we're going to do the linear search. So what is this about? Well, it's very simple. It's shockingly simple. We used a metaphor of finding a name in a phone book and looking linearly through every page of the phone book. And of course, the number of pages in the phone book is analogous to values being stored in memory. And each of the memory locations has an address indexed from 0 to some arbitrary number in. Now, the idea of this in the most basic form is to iterate across the array from left to right in order, not skipping anything, and you're going to be searching for some kind of specified element, that you want to find. Pseudocode, we're going to use this technique. We're going to repeat a routine like in a loop, starting at the very first element in an array. And if the first element's what we're looking for, we're going to stop. Otherwise, we're going to move to the next element. And we have a simple example. As I was preparing for this, I had wished that I made this simple example even simpler because now we have an array with quite a lot of things. In this example, our target is 9, and 9 is right here. 9 is the 6th element in this. It would be at position 5. So we're starting at 0, remember. So we're going to examine the first element, compare it to our target. In the pseudocode, if the first element's what we're looking for, we stop. Otherwise, we move to the next element. So it's not what we're looking for, we move to the next element. 23, we compare it. It's not what we're looking for. We move to the next element. Compare it. It's not what we're looking for. Next element. Likewise, next element. Likewise, next element. Oh, here we compare it to our target and we get it. We stop. So this is an example of a linear search. Got one more example. Maybe this time we're looking for 50. And you can see at a glance that 50 is not in this array. Guess what? That's why I wish I made this example shorter, is that we're going through every element, one at a time. And I'm just going to go back to the end here. We get to the end. We haven't found our target. So what are we going to do? Well, we have to have some kind of ending condition in that case. All right, so we may need to think about that pseudocode and augment it for all situations one might encounter. Now, in general, the worst case scenario for this search, again, we're thinking about efficiency here. Efficiency in terms of how many steps it's going to take to solve a particular problem for a particular algorithm. And the more steps, the worse, So the worst case scenario is we have to look through every element of the n elements because either the target element is the very last element or it's not in the array at all. Okay, that's the worst case scenario. Best case scenario is our target is exactly the first element and we do one step and we stop. All right. So again, we're thinking about our big O and our efficiency. This is quite simple to think about. Linear search, it ain't bad compared to some of the other algorithms, the sorting algorithms. The worst case scenario is we have to go through n. Remember that steep linear relationship? I mean, if it's a small, trivial problem, no problem. But if this problem gets really big, this is not scalable and, it's proportional to the magnitude of the problem. So it actually is super inefficient unless you get really lucky. And our omega could be 1. How lucky do you feel today? How lucky do you feel today? Hope you get that reference. That's all I have to say about that.